Did you know that over 60% of engine performance issues are due to sensor failures? Some of these sensors are very tiny and are often ignored by most car owners. Today, we're zoning in on one small but mighty device that's crucial for your engine's performance: the crankshaft position sensor. What is the crankshaft position sensor? The crankshaft position sensor is a small electronic device, usually cylindrical or rectangular in shape, that consists of a sensor body, an electrical connector, and a magnet. Its location. The crankshaft position sensor is typically found close to a toothed wheel or reluctor ring on the crankshaft. But what exactly is the crankshaft? The crankshaft is a heavy-duty rotating metal shaft inside an engine, designed with multiple offset crank pins and counterweights, connecting to the pistons via connecting rods. And what does it do? The crankshaft is the central component of an engine's rotating assembly. It takes the linear motion of the pistons and transforms it into rotational force, which powers the drivetrain. It also helps synchronize the movement of other engine parts, such as the camshaft and timing system, ensuring smooth operation. Now, why is this crankshaft position sensor so important? The crankshaft position sensor monitors the rotational speed and position of the crankshaft. It sends data to the engine control unit, helping it determine ignition timing, fuel injection, and overall engine operation. But here's the kicker. When the crankshaft position sensor starts to fail, it might send inaccurate signal to your engine control unit, causing the engine to struggle to run properly or not run at all. Stick with me until the end to learn all the symptoms of a failing crankshaft position sensor and what to do. 1. Engine misfires. First, let's understand what happens during a misfire. An engine misfire occurs when one or more of the engine's cylinders fail to fire properly. Now, how does a bad crankshaft position sensor come into play? This sensor tells your car's computer exactly where the crankshaft is and how fast it's spinning, helping to control critical timings, like when to spark the plug or inject fuel. If the sensor starts sending inaccurate or intermittent signals, the timing gets off. Your car's computer, which relies on precise data to function correctly, won't know the right moment to ignite the fuel or release the spark. If the spark or fuel is off even by a fraction, you get a misfire. 2. Hard starting or no start. If your engine cranks but doesn't start, a bad crankshaft position sensor may not be sending the correct data to the engine control unit. Without this information, the ECU cannot accurately determine the position of the crankshaft, preventing proper fuel injection and ignition timing. As a result, the engine may struggle to start, or in some cases, fail to start at all. 3. Check engine light coming on. An illuminated check engine light can be many things, and one of them is a symptom of a crankshaft position sensor issue. When this sensor starts to fail or malfunction, it sends inaccurate data to the computer's engine control unit. Once the ECU senses something is wrong with the signals from the crankshaft position sensor, it generates a specific error code related to the sensor's malfunction. This error code triggers the check engine light to come on. Later in this video, we shall cover the specific error codes that specifically indicate a crankshaft sensor issue. I have added a link in the description below to the best OBD scanner. 4. Rough idling. Your car shaking, vibrating, or sounding rough while idling is one of the most annoying things. But did you know that a faulty crankshaft position sensor could be a culprit? This small sensor helps your car's computer track the crankshaft's position and speed, making sure everything runs smoothly. But when it starts failing, the computer gets incorrect or delayed signals, causing problems with fuel injection and ignition timing. This leads to an unsteady or rough idle. By the way, if you are finding this video interesting, why don't you hit that thumbs up button and subscribe for more insights into how your car works and tips to keep it running at its best. I'll sip some coffee. Done. That's superb. 5. Reduced fuel efficiency. A faulty crankshaft position sensor doesn't just potentially increase your visits to the mechanic. It hits where it really hurts: your wallet. When this little gadget starts acting up, it sends incorrect or erratic signals, confusing the ECU. It might think the crankshaft is in a different position than it actually is, or that it's moving faster or slower than it should be. The ECU might mistime the fuel injection or ignition, causing incomplete combustion of fuel. This means your engine has to use more fuel to produce the same amount of power, which is a poor fuel economy. 6. Delayed acceleration. Your car needs the correct data to time everything perfectly, especially when it comes to injecting fuel and sparking the ignition at the right moment. If the sensor isn't working right, it will send faulty data or no data at all. Your car's computer gets the timing all wrong. When you press the gas pedal, expecting a quick response, the engine hesitates. The fuel injection and ignition timing are out of sync, leading to poor or delayed acceleration. Instead of that smooth, quick increase in speed, you get a sluggish, lagging response. 7. Intermittent engine stalling. A failing crankshaft position sensor can cause the ECU to lose track of the crankshaft's position, leading to incorrect fuel injection and ignition timing. When the ECU doesn't receive accurate data, it may fail to deliver fuel at the right moment or misfire spark plugs, causing the engine to momentarily lose power. This leads to intermittent stalling, as the engine momentarily loses power or shuts off completely. Stalling can happen unpredictably, sometimes while idling or even while driving, making it a serious safety hazard, especially at high speeds or in traffic. 8. Difficulty shifting. Automatic transmissions. In automatic transmission vehicles, the ECU relies on input from the crankshaft position sensor to manage engine speed and coordinate gear shifts. A failing sensor can send incorrect or erratic signals, causing improper timing of gear changes. This can result in hesitation, rough shifting, or even failure to shift at the right time. The transmission may go into limp mode to prevent further damage, severely limiting vehicle performance. 9. Irregular RPMs or tachometer readings. The crankshaft position sensor provides critical data to the ECU, which in turn controls the tachometer. If the sensor sends incorrect or intermittent signals, the ECU may misinterpret engine speed, causing the RPM gauge to fluctuate erratically, freeze at a certain reading, or stop working entirely. This erratic behavior can make it difficult to gauge engine performance and diagnose other potential issues. 10. Strong or unusual exhaust odor. A bad crankshaft position sensor can cause incorrect fuel injection timing, leading to an improper air-fuel mixture. If too much fuel is injected into the combustion chamber, or if it isn't burned completely due to poor ignition timing, unburned fuel may exit through the exhaust system. This can create a strong gasoline smell or an unusual foul exhaust odor. In severe cases, excessive unburned fuel in the exhaust can damage the catalytic converter, leading to costly repairs. Crankshaft position sensor error codes P0335, crankshaft position sensor AI circuit malfunction. This code appears when the ECM cannot read the sensor's signal. P0336, crankshaft position sensor AI circuit range DARS performance. This indicates a problem with the sensor's performance. P0337, crankshaft position sensor A circuit low input. This code signals that the sensor's voltage signal is lower than expected. P0338, crankshaft position sensor AI circuit high input. This error indicates a higher than expected voltage signal. How to test the crankshaft position sensor. Here's a step-by-step approach. Step 1. Locate and access the sensor first. Locate your crankshaft position sensor near the engine's bottom front or mounted on the transmission. Make sure your vehicle is turned off and safely positioned before you proceed. Step 2. Check for visual damage. Visually inspect the sensor for any cracks, abrasions, or oil contamination. These can often indicate a problem before you even test its functionality. Step 3. Measure the resistance using a multimeter. Set it to the resistance setting and connect the test leads to the sensor's terminals. Refer to your vehicle's service manual for the correct resistance values. The normal resistance should be within a range of 200 to 1000 ohms. A reading far off from the expected range suggests a faulty sensor. Step 4. Perform a voltage check. Crank the engine and measure the voltage output with your multimeter. The reading should show a small voltage of between 0.5 to 5 volts. If there is no change, the sensor may be faulty. How to test a 3-wire or Hall effect sensor? These sensors typically have 3 wires. 1. Power wire or Odor, 5 volts or 12 volts from the ECU. 2. Ground wire. 3. Signal wire, Odor, outputs a digital pulse to the ECU. Here is a step-by-step process. Step 1. Locate and verify the 3 wires. Identify the 3 wires of the sensor, the power supply, usually 5 volts or 12 volts, the ground, and the signal output. Refer to your vehicle's wiring diagram to accurately identify these wires. Step 2. Check supply voltage. Connect your multimeter's positive lead to the power wire and the negative to the ground wire. Turn the ignition on, but keep the engine off. You should see a stable voltage that matches the sensor's required supply voltage, usually 5 volts or 12 volts. This confirms the sensor is receiving power. Step 3. Connect the oscilloscope. Attach the oscilloscope probe to the signal output wire and connect the probe's ground clip to a good grounding point on the vehicle. Step 4. Configure and observe oscilloscope readings. Power on the oscilloscope and set it to display a digital signal, then crank the engine to display the signal. Watch the oscilloscope's display for a clear, consistent waveform pattern. A properly functioning Hall effect sensor will produce a square wave or a similar waveform that changes with the position of the engine part it monitors. Step 5. Analyze the waveform. Examine the waveform for consistency and amplitude appropriate to the sensor's specifications. Variations in the waveform can indicate issues like sensor misalignments or faults. How long can you drive with a bad crankshaft sensor? You can drive a few miles to several days, but it's risky. A failing crankshaft sensor can cause stalling, misfires, or prevent the engine from starting. If it fully fails, your car won't run at all. Fix it ASAP to avoid getting stranded. How much does it cost to replace a crankshaft position sensor? The price ranges from $150 to $450 depending on the make and model. This includes the cost for parts and labor. The parts cost between $60 to $150, while labor cost range between $70 to $250. We've just covered the symptoms of a bad crankshaft position sensor, the error codes, and how to test the sensor. To keep your car running smoothly, hit that like button, subscribe, and watch our next video on camshaft position sensor problems.